My name is Vianney Mesige. We are at the Green Heat offices in Kampala. At Green Heat, we are collaborating with CREEC and other partners on a project where we are looking at water hyacinth as a possible feedstock for biogas production. So at Green Heat, we are running a number of experiments where we are using reactors and we are feeding the reactors with water hyacinth. So we are going to run a number of experiments without controlling the temperature, because we believe most of our digesters out in the field are not temperature controlled. Then the other experiments that we ran were where temperature is controlled. Basically, is to compare how much more gas we generate when temperatures are controlled and versus when temperatures aren't controlled. Then the other experiment that we want to do is a cold digestion experiment, where we are going to mix the water hyacinth with a number of different feedstock. We will look at the fecal matter, we will look at food waste. The entire idea is to use feedstock that is available in the field, say in schools, people's homes, and then see how much gas can we generate, and then how much impact can we have out of the lab. So we've managed to plant small ponds at the office with water hyacinth. So we collect the leaves, we collect the stems, crush them, put them in the reactors, and then some of the lessons we are learning from the office experiments, we are transferring them to the MPG facility. So in the MPG facility, it's a bigger digester. It resembles what we have in schools. It's big enough, 30 cubic meters. It has the toilet facility. Then it also has the end point where the gas can be used. So some of the lessons we're learning from the experiments done in our office, we are transferring them to the MPG facility. Then from the MPG facility, we shall transfer the knowledge and experience to the schools. Now, some of the challenges we've observed at our ponds in the office, we are seeing mosquitoes bleeding in these ponds. So some of the aim at our MPG facility is to try as much as possible to monitor how much more mosquitoes are we going to have in MPG as a result of having water hyacinth growing in that area. Then the other thing is the safety because getting a pond that is in PG, putting it in a school, it has a lot of safety issues. So there are a number of issues we have to address, like fencing off the facility or the pond, ensuring that kids can't easily just fall into such ponds. So also reducing the size, because the size that we've done in PG, since it's more of a controlled site, we believe that size is good enough for such a facility. But in schools, such a size would be too big. So we have to monitor how much water hyacinth are we going to grow, and how much gas how much gas are we going to get out of that biomass we collect from the ponds. But the ponds are going to be smaller, not as deep as what we have in PG. The other thing that we also want to monitor is the purity of the gas, because biogas has a number of impurities in it. So the experiments we're running here, we are taking off the impurities, but in the field we are not able to do it. So we want to find an affordable method of purifying gas in the field using the experience we're having in our office. So we believe the BEFWAM project will feed into our larger program of biogas systems in Uganda or in Africa, where we want to put up more and more biogas systems, but using different feedstock gives us more ability to put up more systems. For people who don't have animals, we are able to say we can put up a water hyacinth pond and then get feedstock from the water hyacinth pond. So that we take away the narrative that biogas only comes from cow manure. There could be other feedstock that could generate the gas. So the idea is to explore more and more feedstock sources, and then for us we believe water hyacinth is one of them, and we are confident that it will have a huge impact in the biogas sector. So over the past couple of weeks and months, we've been able to establish partnerships with a number of schools. So far we have St. Teresa and Bishop East. These were some of the schools we have worked with in the past through the Ministry of Energy. So the Ministry of Energy has facilitated the transition it has facilitated and allowed us to use some of their projects as experimental grounds for using water hyacinth as a feedstock. After seeing the small ponds where we're growing the HYACINTH at the Green office and the small bioreactors in our lab, let me take you to the PG site where we are scaling up the experiments. We are at our demonstration site in Mpigi, where we have a 30 cubic meter digester. We have put up 2 ponds where we are going to grow HYACINTH. The HYACINTH is going to be grown from these 2 ponds, harvested, brought into this digester for digestion. So the entire idea is to pilot the growth of the HYACINTH such that we can learn from the mistakes we are doing on this demonstration facility, and then we iron out the planting bit of the HYACINTH, and then we can take the knowledge to schools. Many of the schools where we want to work have similar digesters. Theirs are a little bit bigger than what we have here. However, because of the lack of enough feedstock in schools, we want to use HYACINTH as an alternative feedstock to supplement on the feedstock that the schools are currently using. So in here we are able to harvest HYACINTH, put it in a digester through the feeding point, and then the HYACINTH will be digested. The digester is underneath. So the idea is once gas is generated, we are able to quantify how much additional gas are we getting by adding the HYACINTH into the digester. Then that additional gas can be monitored at the end of, we have a gas meter on the end, so we can easily quantify that gas, that extra gas we generate, and then we can easily tell the impact the biogas is going to give because of the feedstock, the new feedstock we're using.